This is chapter 2 and we're going to learn about the instructions and the operators in C language. Now, the type of instructions in C language are: number 1, type declaration, in which we declare the type of the variable. There are arithmetic instructions and control instructions. Now, the example of type declaration are int a semicolon. Here we are telling that the a variable is of integer type. So that's why the name is type declaration. Other examples can be char a semicolon. Here the things to be noted is that whenever we write a character, the variable of the character is written in closed in what are those called, single commas, yes. Other examples can be float b semicolon. Now here the float b tells us that the b is a type of data which can be of point type, like not point, basically decimal, like 0.1234. Now if we'll write, like for example we'll write a program in boilerplate, and we write first we write float b is equals to a plus 3 semicolon, and in the next line we write float a is equals to 1.1 semicolon. So what will happen, that our program will throw an error. Why will our program throw an error? It will throw an error because we have not defined a and we used a a earlier in our statement. For example, first I used float b is equals to a plus 3, and here I had not defined a. So this program will throw an error because we are using a before defining it. Now in arithmetic we have certain operators the same as we have in mathematics, like plus, minus, multiply, divide and percentage. Now the percentage sign is called modulus. Like when you write a percentage sign in the program, it will perform the operation of modulus. More on this later. Now the numbers like 1 2 3 4, minus 1, minus 1.234 are called operands. Now coming to the modular operator, percentage is called modular operator or also division operator. What does this operator do? It returns the remainder. For example, if I have written 2 percentage 2 in a program, and in a program, yes, it will return 0 because the remainder when we divide 2 by 2 is 0. Similarly, if you write 3 modulus 2, it will return 1. Another thing to be noted is that modular function cannot be applied on float. You cannot write like 0.234% 2. You cannot do that. Also, what will be the sign of the numerator will totally depend upon what is the sign of the what will the sign of remainder totally depends upon what will be the sign of numerator. For example, if I write 5 modulus 2, the remainder is 1. If I write minus 5 modulus 2, the remainder is minus 1. If I write 5 modulus minus 2, the remainder is 1. Okay. Also, the thing to be noted in C language is that no operator is assumed to be present. For example, if in mathematics, in your notebook, you have written a variable x, and in adjacent to it you have written y, then you assume that it is x multiplied by y. But in C language, what we do, that if I have written int I is equals to a and another variable b without specifying any other operator in between them, then it is invalid. We cannot assume that it is a multiplied by b. Also, no operator to perform exponentiation. You cannot perform exponentiation in C, but what you can do is that when you write a general program and start with hashtag include, if you'll write in that hashtag include and you'll write math.h enclosed in tilted v's, then you can use this you can perform exponential operation. But how? The function that you'll be using will be pow in a bracket x comma y. Now if an arithmetic operation is performed between integer and integer, you will get an integer. If it is performed between integer and a float, then you will get a float value, and float and a float, then also you will get a float value. For example, 5 divided by 2 will give 2, 2 divided by 5 will give 0, 5.0 divided by 2 will give 2.5. okay. If you'll write int a is equals to 3.5, then 3.5 is a float. Hence, when you'll run the program, what will happen that because you had defined a as an integer, then 3.5 will get demoted to 3 in order to produce an integer. Similarly, if you'll write float a is equals to 8, what will happen that a will be in the output, it will be given as 8 point, and depending upon how many zeros your system is producing after the point, a that is 8 will get promoted to float value. Now if you'll write, there's a question, for example, if you'll write int k is equals to 3.0 divided by 9, then what will be the value of k? See, the first thing to be noted here is that a float and an integer are being the arithmetic operation is being performed between a float and an integer. Okay, so by that logic you will get a float, and 3.0 divided by 9 you will get 0.333. But now you have to go one step further by seeing that you have written int k is equals to this value. So because this whatever the value of k comes, it will get demoted as a integer. So you had got 0.333. now this value will get demoted to 0. So the final output, if you are doing this operation in C language, will be 0. Now if we'll come to operator precedence, this means that which operation is applied first. For example, in maths we have BODMAS rule. Similarly, in C language we have this rule that multiply, divide and modulus function are given precedence over plus and minus, and the last precedence is given to equal to sign. Equal to sign here assigns value. Okay, it's not equating value. More on that later. So the first preference is given to percentage, division, modulus. Second is given to plus, minus, and third is given to equal to. Also, the thing to be noted here is, for example, in a let's say in a statement, the multiply, divide and modulus, all three of them are present, then which operator will be preferred? So what you will do here is you will apply associativity law from left to right. For example, if you have written 3 multiplied by 2 divided by 6 modulus 4, let me repeat, let me make it easy. 1 multiplied by 2 divided by 3 modulus 4. So you will begin by forming groups of 2 from left to right. For example, first you will operate 1 multiplied by 2, that is 2. Now you will operate 2 divided by 3, that is 0. Not sorry, yes 0. 0 point, it will be demoted, you will get 0. Now it's 0 divided by 4. Okay, this will be performed. And if there are no parenthesis, the operator of higher priority is evaluated first, and this implies that if there are parentheses, of course, that you will do the operations which are in parenthesis first. For example, if we have 1 in a bracket, we have 1 multiplied by 2 plus in a bracket we have 1 plus 2 multiply by 3. So now you cannot say that the first precedence is given to multiply, so we will multiply 3 by 1 and then 3 by 2. You will first solve whatever the thing is in a bracket, and then you will proceed by multiplication. Okay, this I have already said, that operators which have equal priority, then associativity law is performed. Now control instructions. What are control instructions? The control instructions are instructions which are used to determine the flow of control in a program. More on them later. For the control example of control instructions are sequence, decision, loop, and case. Loop you will study very soon. So control statements, control instructions basically determine the flow of control, in which direction the control is going in a program. Okay. Now coming to some questions. If you have written int a semicolon and b is equals to a semicolon, this is an these will be invalid statements in C because b has not been declared yet. It would have been okay if you have written int b is equals to a. Similarly, if you have written int v is equals to 3 and you have used that sign which you used for power, upside down v and 3. Now you might think that because exponentiation is not valid in C language, so it must be invalid, but that's not the case. This function is valid. Similarly, if I have written char dt is equals to, in what are those called? Not semicolon, double quotes, single quotes. In single quotes, I have written 21 December 2022 semicolon. So naturally or usually you might think that this is valid, but what will if you run the program in C language, you will find that this statement is invalid. Why it is invalid? Because it is too long. If you have written just character dt is equals to a in a single quote semicolon, it would have ran, but this character don't store so much data that we have written. Okay, so this will be invalid. Another thing to be noted here is by default the numbers are stored in double and not in float. Double is also numbers with decimals, but are larger in storing capacity than float. So when the question is what will be the data type of 3.0 divided by 8 minus 2, so first we will give precedence to the division, of course, and then we will write 0.375, then we will subtract this by 2, we will get minus 1.625. So one might say that we will get float, but what happens that in C language by default the real numbers are stored or are stored in a data type of double. So the more appropriate answer would be double. Now we have to write a program to check whether a number is divisible by 97 or not. Okay. So starting from the start, we have to find out whether the number is divisible by 97 or not. So the first thing which might come to your mind, that which operator to use. So usually in your mind it will come that we can use modulus operator. If the answer upon doing the modulus is 0, then the number is divisible by 97, and if it's not 0, then it is not divisible by 97. So writing the program step by step, first of all I am writing hashtag include, and in the brackets which look like horizontal V, I am writing studio stdio.h. In the next line I am writing int main and parenthesis. Then I am writing curly braces, opening a curly braces, and I am writing int a semicolon. Print f, in parenthesis I am writing in double quotes enter a number, and I am writing %d and \n. Then at the end of the statement I'm writing a semicolon. Then I'm writing scanf, in the parenthesis I'm writing in double quotes %d, and after the double quote end I'm writing comma, then I'm writing and a, and I'm writing semicolon. In the next statement, in the next line, I'm writing printf. In bracket, I'm writing in parenthesis and in double quotes, I'm writing the remainder when given number is divided by 97 is %d, comma, a %97, bracket closed, semicolon. Then I'm writing printf. In the remainder, sorry, in the double quotes, I'm writing if the remainder is 0, then the number is divisible by 97, and if the number isn't 0, so the number isn't divisible by 97. \n, statement complete, semicolon, return 0, semicolon, what is that called, curly braces closed. If you'll run this program, so